we have a few talks left. Next one is a remote talk. We'll see Asko Soukka and Nicolas Polveg to talk on the screen soon. They will be talking today about web-scale robot framework with JupyterLite. Let's give them warm welcome onto the screen. Thank you.
Hello, RoboCon 2022. Welcome to our talk, Web-Scale Robot Framework with JupyterLite.
And talking to you today is going to be myself, Nick Bolweg, and I am with Georgia Tech in Atlanta, Georgia.
And I am Asko Soukka from University of Jyväskylä, Finland.
Awesome. Well, it's really good to catch up with you, Asko. It's been a couple of years. Because pandemics and stuff. So it's 2022. What are you excited about in the broader robot framework ecosystem?
Yeah, there have been some releases after we last saw. And the latest one is Robot Framework 5. And there's one specific feature I want to show you. And it's that new try except syntax where you can capture any exception from your code you are calling and then do something with the error. So I'm one of those guys who do RPA, so automation, with Robot Framework 2. And they are not all errors are equal. And sometimes we don't want the whole test or whole task run to fail. We want to capture the exception, like here. So we are using the try syntax, and here is built-in keyword fail something. And now with the except as some variable name, we are capture the error message and then do something with it. Like here we are displaying it. So if I change the error message, so like this, then we can capture the error message and do something with it without failing the whole test case. And really see how it also works from Python code. Let's write a small Python keyword library very quick. So Python module my keywords. Let it be class my keywords, and let it be a library that maybe calls some API and do something with the data. So fetch some data. But now we are calling it at the wrong daytime. So we want to capture that error message that we are really calling it from daytime and on the higher level, and then maybe run this task later again. This is like a business error. And then you just be able to use it from in our robot code. Let's import the library. So settings table library and my keywords like this. And now we should be able to use our keyword in this example robot test or task or this task. So let's fetch some data. Like that.
Oh man, that worked great.
So that's so much simpler than it was in the previous version. I really like that. I will be using this a lot in the future.
Yeah, absolutely. I mean, you'd have to go look in the console log or go find it inside your HTML output. That sounds pretty tedious. So good, definitely good. You know, you compare that with all the other stuff that came out in Robot 5. This is really exciting stuff. But I guess we better get to our actual talk now, right?
Yes, let's go forward.
Sounds good.
So that was JupyterLite interactive computing environment with Robot Framework support, being able to scale with the web, running completely in browser with no backend servers required. It's really good to be back here again. So we were last time there 3 years ago. That is our second RoboCon together. And 3 years ago we presented Robot Framework support for Jupyter Lab and Jupyter Notebook.
So Jupyter, for those that haven't encountered it before, is a series of interactive tools that enable folks of all levels of computational knowledge to do computing interactively. So what we've done in JupyterLite is go from something that requires a bunch of servers, you might have some Docker containers, you might have some things in the cloud, to something that runs entirely in your browser. And we're really excited to share that to you today and talk a little bit about Python, a little bit about JavaScript, and of course about some robot framework.
So what has happened after we last were here? So at first I really want to give some credit for RoboCorp. So RoboCorp did take our work and built the RoboCorp Lab product on top of Jupyter Lab with RobotKernel. And for a couple of years, they worked really hard to popularize Jupyter Lab as Robot Framework developer tool. And that they call it RoboCorp Lab. Well, this year they seem to have abandoned the lab for some reason, but I like to see its legacy still alive in the VS Code interactive console. So that's a feature that is provided by Robot Framework LSP extension for VS Code, and it's looked like that. This. So the interactive console is a special Robot Framework window next to the currently open document, and similar to notebooks, it provides long-running Robot Framework environment to quickly try out Robot Framework keywords and iterate on your test and task fast. So it's not a real complete Jupyter experience, but well, it's still something.
So meanwhile, over on the Jupyter space, we've seen a rapid iteration with a major release every year since we released. So the current iteration that we're working on right now is JupyterLab 3. JupyterLab 4 will be coming out sometime this summer. And it's the most supported iteration of the Jupyter clients available right now. JupyterLab can be installed with pip. It can be installed with Conda. It's coming to other package managers near you. And there's also a desktop browser version of it that runs inside of Electron.
I think my favorite feature of the latest JupyterLab is that also the front-end add-ons can be installed with installed from Python packages with simply pip install something. So in the previous version, you had to also have Node.js available and rebuild the whole front-end.
And it's really that improvement on the federated extensions that allowed us to build JupyterLite. So we're really excited to show you some more about that in just a sec.
Also thanks to RoboCorp, we have a new Robot Framework related add-ons available for JupyterLab. So they did make our Robot Framework syntax plugin for JupyterLab in its own package. That's available at Robot Framework community organization and GitHub. And then also they funded development for complete new Robot Framework kernel for JupyterLab called Xius Robot, and that one supports also Robot Framework LSP and JupyterLab debugger support through that. So it's really everything we kind of promised 3 years ago. But now let's get back to our main topic. That's JupyterLite. And here's another example of JupyterLite running. So we can have interactive Robot Framework authoring experience on the left, and we can even have contextual help for the keywords. So keyword help available. When you click a keyword, I get help for the keyword. And we can also bring in other features from the JupyterLite and JupyterLab ecosystem, like having Drawio here embedded for drawing graphs, and having Jitsi for video conferencing. Of course, we have collaboration mode for editing with your friends. And all this runs 100% in browser. And all the basic features work completely from static web hosting, and only those interactive features, collaborative features, require some third-party services, which usually are also possible to run on your own if you require that. For a user, using JupyterLite is as easy as opening a web page, really nothing more, and it's available always when the web page is available. So that's basically all the time, no downtimes.
If you are the content owner and you are hosting that website, you get to enjoy the fact that pretty much static hosting is free. And you are not going to, as you add more people, you're not going to incur more costs. Contrast this with something like Kubernetes, where every extra person that you add, you have to launch another container. So that allows you to really manage the amount of money that you're going to be spending on delivering interactive content. Because of this simplicity, this gives you better security. So for you, as the content owner, you don't have to expose things that can dip into your checkbook and cost you money. You don't have to put users' data out in front any more than you normally would. If you're getting your third-party authentication, you don't really need to keep anything about them. For your users, they get to keep their data inside their browser, which is a place that they already trust. And so they're not having to share their data, put it in the cloud, anything like that. On the main, this means that your whole application is more secure and gives you opportunities to avoid whole classes of problems that come with a robust interactive computing experience.
And once again, what all this means in practice. In practice, we can host these live example environments right from static free web hosting. For example, here we have our RobotKernel documentation at ReadTheDocs, so robotkernel.rtfd.io, and we have a little form, launcher form here. So just by clicking that JupyterLite button, you can have sole experience for you to try out RobotKernel in JupyterLite, or if you want to play it with your friends, you can enter room name in that nobody else form, and then your own name, and then you can hack robot with your friends without installing anything. Just go into our documentation and clicking and filling that form and clicking that button. And compare that to what we had to do when we were holding workshops here at RoboCon 3 years and 2 years ago. So we had to build 600 megabytes installer that contained all this stuff for 3 different operating systems, Windows, Linux, and Mac OS, to make sure that all the participants had working environment. Now, today, we would be able to do most of that workshop just by hosting JupyterLite somewhere and providing that URL for the participants. To summarize what JupyterLite is.
What we've been trying to do in JupyterLite is provide an extensible framework for browser-based interactive computing. It's an authentic Jupyter experience that allows us to reuse all kinds of extensions from all over, and usually doesn't require that much rework. All you need in order to give this to users is a static HTTPS host. And with a little bit more work or a little bit more trust, you can provide real-time collaboration and video conferencing and other interesting services with third-party servers or your own self-hosted ones. The simplicity allows you to embed it within larger applications that handle other things like storage and authorization and authentication. And all this is powered by Python and Robot as compiled to the browser by Pyodide. We're going to see Pyodide in a bunch of other places. It runs in Node.js, so that means we're going to see it over in other applications like VS Code. And it runs by itself in browsers, so we'll see that in other websites that don't provide a full Jupyter experience with contents and widgets and all that other fun stuff. On the main, what this provides us is a better security environment that we can use to do interactive computing without having to have the requirements of full fat servers that can change every file on your system. So for learners, this is great, and for hosts, this is great.
You may have seen or even tried the new Getting Started section at robotframework.org, which provides also in-browser code editor with executable robot framework examples and is based also Pyodide as JupyterLite. But JupyterLite provides the tools to build your own with your own editor with your own examples. And that's pretty easy. So you simply have clean Python environment, install JupyterLite with the feature you need. Here we run JupyterLite with contents feature that allows you to then build your JupyterLite with your own examples. And that JupyterLite build command produces output directory with fully working JupyterLite site that you can then upload to your server and serve there or serve it locally. And how to add Robot Framework into that mix is to use our integration package, JupyterLite-RobotKernel. So it's as easy to use, so just pip install JupyterLite-RobotKernel and then build it with your examples. So that should be perfect for building your own interactive documentation or with your own tutorials or material for holding your own workshops. Next, let's see how easy it is to create your own JupyterLite site. So to start, we need clean Python 3 virtual environment. I call ours JupyterLite Builder, like this. And once we have the environment, we need to activate it. This depends on your system. On Linux, I source the pin activate script from the environment. And next, I should install our integration package, and that was called JupyterLite RobotKernel. And now people will install everything required to create our site. So it gives us that JupyterLite command we can use to build manage our JupyterLite sites. And we have a folder of example notebooks we want to include in that JupyterLite site. So we call it with JupyterLite build -- contents and notebooks, like this.
And so it did a bunch of that stuff fast up front, but now it's going to download a bunch of wheels. And the reason we want to download all these wheels, because it's not shipped, all the Pyodide kernel stuff that ships directly with JupyterLite today, we're not going to have that stuff for the robot kernel. So this ensures that we have everything that we need, that when we try and run that thing in the future, all those wheels at versions that we know and can predict are going to work. Because trying to recover from a broken environment, which is already a very dangerous thing on a real computer, is really hard inside the browser. I mean, you can just reload your page and it'll just work. But
and it's also faster because it doesn't need to go all the way to PyPy to fetch those fields all again. So now when the build has been completed, we have a directory called output that contains our brand new JupyterLite site. It's now ready to be pushed to static web hosting to be used. We can also test it locally by running JupyterLite server command. It accepts port parameters to give some free port we have available on our system. And then we just copy this address on our browser like this. And as you see, we have our own custom JupyterLite build running on our browser with our example notebook. We can just open and then run and see that it really works.
And so that fan that you hear spinning is because we're actually creating a virtual computer inside of his browser right now.
Yeah, but now we have it run. We did run all these tasks and keywords, and we have all the features we have used from our RobotKernel. For example, we can test our keywords with this keywords button, and then check our logs. How did it all go? So that's how easy it is to create your own JupyterLite environment. Once you have your own JupyterLite build, installing add-ons and customizations is as easy as installing new packages into your build or build virtual environment and then rebuilding your site. For example, if you want to have your own theme, you just find out existing theme, then customize it, build it in the Python package, and then install it into your virtual environment and rebuild your site, and boom, you have your own branded JupyterLite experience.
So all these things are really nice, and we're able to reuse a lot of stuff. However, not everything is going to work exactly the same way. First off, the big thing is it is still in beta. Things are still changing, and we're doing the best we can, but things are still in motion. If you have a very complex add-on, like something that uses Git or subprocess, that's probably going to have to be configured specially. We had to do that for the video example that you saw earlier. Browser Sandbox has some limitations, and we use web workers, for example, to limit the interaction between the host application and the actual running kernel. Some of these can be a little bit awkward. For example, we can't get files very easily into the kernels, and we're working on that. You also don't have things like network, where this mostly comes into plays for very complex but very beloved libraries like SSH library or Selenium library. We can't launch new processes, and we can't connect to random arbitrary ports. So there's a fair amount of things that'll have to change, be shimmed, whatever. Another big limitation is that it only works with Python, pure Python wheels, and special and Script32 wheels, of which there are almost none. So this means in the near term, there's some definite limitations on what you're going to be able to install. And if you do need it, you might have to use some shims. We did things like that for some of the Jupyter library or the Jupyter packages themselves. And things will get better, but that's just where we are today.
Finally, we'd like to show you an example where JupyterLite makes it possible to embed the Jupyter experience for Robot Framework test and task authoring right in the third-party web application. This is Camunda Platform, Camunda Platform 7 to be exact. Camunda Platform 7 is an open source process and decision automation platform based on PPM standard and microservice orchestration. This app we see here is called Camunda Cockpit. It is a web application designed for monitoring and interacting with the processes managed by the platform. And by web app, I mean that like any modern web app, it runs in browser and does its job by calling the platform REST APIs. And it's also extensible. That makes it possible for us to embed JupyterLite right into it, mostly by just following the documentation of both JupyterLite and Camunda. And by the way, this example we see here, this example process, it's actually an adaptation of a RoboCorp course example. So it's a simple data loader process for RPA that which loads a table of data from a source service, does some transformation, and then submits it line by line to a destination service. Next, let's see how our embedded JupyterLite looks in action. Here we have the Camunda Cockpit web application. As we heard, it's the main application of Camunda Platform 7. And right here, it shows that there's only one process available on this Camunda instance, our example process. But look what's up here, right at its main top toolbar. we have a link to launch our embedded JupyterLite right here. So let's try it. Let's wait a few seconds. And here it is, fully working JupyterLite embedded seamlessly right inside our Camunda cockpit. So what would we do with this Jupyter and Camunda? We could do the usual Jupyter stuff, call Camunda REST APIs to fetch some data and from the complete processes, for example, analyze the data and draw some graphs. Or we could do scripting and call the Camunda REST APIs for some batch or maintenance work, and then say the notebooks for later use. But of course, because this is RoboCon, we can also use Jupyter to write tests for the processes available on this Camunda. And here we have an example test suite running the example process we just saw. So let's run this test and see what happens. And now, thanks to combining all this technology, Camunda technology and JupyterLab and Robot Framework, we were even able to visualize the process while we are testing it. So here, let's run we have test case called full coverage. And while we run the test case, we are able to visualize the test coverage of the process while we are testing it. And now, when the test has been completed, we can visually confirm that yes, we have really tested all the edges of this process. This process is now fully tested. And even better, when something goes wrong, from the visualization, we can very quickly see what actually went wrong while testing the process.
Wow, thank you. That was a really cool demo, Asko. So what do you think people are gonna be able to use these tools for, like Camunda and JupyterLite? I mean, is this a thing people are really gonna be able to use?
Well, at least it makes fun demos at conferences.
That's true.
But seriously, yes, we are already using it in production, despite your warning. So we are using JupyterLite for doing some maintenance on our Camunda processes and analyzing data from the processes. But I'm looking for the future also use Robot Framework integration to actually let our process developers to do tests for the processes to deploy right inside Camunda.
Oh, that's really exciting, and that kind of dovetails with the things I'd like to see, where you're using JupyterLite as part of your software development process, embedded right inside of GitLab or GitHub or Fossil or something that you can host yourself. So I think it's really exciting, and there's a lot of cool stuff coming up.
I think that concludes our presentation today on making Robot Framework web scale with JupyterLite. So thank you all for your participation in RoboCon, and now we are happy to answer your questions.
Thanks.
Wow, thank you, Nick and Asko. We have some questions. Feel free to post more questions. I think we have more time questions this time. Hello, Nick and Asko. Can you hear me?
Yes, good morning.
Excellent. Well, good morning to you too.
Good afternoon, I'd say.
We have some questions for you. How many users can be connected?
That kind of depends. With the Jitsi plugin that we were working, that would be a hard cap at 16, 20, something like that. With a normal JupyterLite site, there's really no limitation because there's no open connections. So one GitHub pages could serve tens of thousands of users.
Excellent. Is there some kind of tutorial online available?
For RobotLite, we have some stuff embedded inside there and some starter content that Asko's been maintaining over the years. On JupyterLite, there is documentation on JupyterLite.readthedocs.org, and there we are currently in the process of improving the tutorials, but there is a good amount of documentation.
What was the biggest problem you had to kind of tackle to get all this working? Because to me, it's like this sounds like a really big project.
If Asko wants to take that, I want to give that to him. He did some really neat stuff for this one.
Well, I think Jupyter project has done the most work. So I quite easily migrated or added support for my old Python kernel for the Jupyter or normal JupyterLite for the JupyterLite. But I think the biggest work has been in Jupyter community how they make the new Jupyter lab so that it was able to you are able to run that lab completely in browser, and you only had to make also those kernels run in browser.
Good. Is importing .robot files supported?
Yes, but there's no easy way to get them inside the computer yet. So you can use the built-in pyodide fetch capabilities and fetch files from someplace. If you know the URL of them, you can bring them down and then you can import them. We are working on a better approach for unifying contents. So I upload a notebook, and now it's available to the kernels, to all of the kernels. I write a file with one kernel, it's visible to another kernel, and it's kind of prickly stuff. But we're very excited about that.
And maybe continue a little with the normal lab that requires backend. On that, there is a plugin that can open robot files directly as notebooks, and also save those notebooks transparently back into robot files. I guess once that JupyterLite backend frontend get support for more files, then we can try if we can get that add-on also work for JupyterLite. So the good thing is that huge Jupyter ecosystem, and now when it seems that Jupyter ecosystem is also adapting JupyterLite for their demos, more and more add-ons will come to support also JupyterLite by default. So we are getting benefits from that ecosystem.
All right. Thank you, Asko and Nick. I don't think you heard the applause previously, so let's once more give the maximum amount of noise to Nick and Asko. Thank you, Nick and Asko.
Thank you.
Thank you so much for having us.